All right, going back to example 1 of making a box with 108 square feet, maximizing its volume. We've drawn the picture. We're going to move to step 2 now, which is to determine the constraint equation. Okay, so step 2, the key word here is the constraint equation. You know, constraint means to kind of limit the possibilities or to create boundaries. And so I want to be very clear about the difference between that and optimization equation, and we will go from there to solve the problem. Now, this one's pretty easy. You know, you've only got 108 square feet of cardboard to work with, so you can imagine that that's your constraint. Okay, if you had more cardboard, then you could be able to make a bigger box. So you are constrained by this amount of cardboard, and therefore our constraint equation is going to involve surface area. Now, what is the surface area of this box? Notice that we label the fact that it's an open box. So it will only have the 4 sides plus the bottom, which is 5 sides. Well, the area of the bottom is just x squared. The area of any one of these sides would be x times h, and since there's 4 of them, that would be 4xh. Putting that together, the surface area would be equal to x squared plus 4xh. And therefore, we can plug in 108 for s, since that's how much surface area we have to deal with. So now we have 108 equals x squared plus 4xh. Another way to think about the constraint equation is it will not involve what you're optimizing. So you might be thinking, okay, well, what are we optimizing? Well, if you read the question, it says that we want to make the box with the maximum volume. So since that superlative maximum or greatest is attached to volume, then that means that that will be our optimization equation. So the other figure they gave you, the square footage figure, must be your constraint equation. In other words, your constraint equation is going to be square feet, because that's the other figure they gave you, not the volume, but not what you're optimizing, the other thing that you're dealing with. And you'll see this as we go along. More examples, you'll get the feel for the difference between the constraint and the optimization equation. But again, you're constrained by the fact that you only have 108 square feet of surface area. Okay, let's look at step 2 for example 2. Now again, you know, you can think of constraint as being limited with what your resources. We have these 2 shapes which have perimeters. Maybe they're formed by wire or something. And we only have 10 inches to work with. Let me see if I can go back and look at what we had before. We only have 10 inches of this. Let's say the wire is purple. Well, that we are constrained by that, right? So our constraint equation in this case is going to involve perimeter. Okay, and so what is the perimeter of these 2 shapes? Well, it would just be x plus x plus x plus y plus y plus y plus y equals the perimeter. So 3x plus 4y equals 10, the amount of wire we have to deal with. So we have 10 inches of it, so 3x plus 4y equals 10. Pretty easy, right? So again, the constraint equation involves basically what your resources or what you're dealing with, whereas the optimization equation, which we'll talk about in the next video, involves what you're trying to optimize. In this case, you're trying to optimize area. Okay, so let's take a look at example 3, step 2 for it. Now I'm going to pause this for a second and basically quiz you. What do you think that the constraint equation will involve in this problem? Well, we'll give you one hint. You're trying to maximize monthly profit. So that will not be your constraint equation, will not be your profit. It will be something else involved in this question. So I want to break this down one kind of step at a time, at least my process for figuring out the constraint equation. If you think about it, you're limited by, in this particular example, by the number of apartments you have. I mean, you've only got 30 apartments, so that's going to be a constraint on how much profit you can make. And furthermore, you can really only make profit on the number of occupied units. Okay, so your number of occupied units is what's going to be your constraint equation. Now, I started out with just writing kind of my thought process out in words for this one. And again, this is definitely the more challenging problem of the three. So I'm going to slow down a little bit with this one and break it down some more. So the number of occupied units, this is a simple equation, is going to be equal to the total number of units, which is 30, minus the number of vacant units. So let's say we know we have 30 units total. Let's say we have 10 vacant units. Then there would be 20 occupied units. So we're going to replace the number of total units with 30. Now, the other part, the number of vacant units, is a little bit more complicated, and want to basically show you how we get from here, replacing it with R minus 1,000 over 40. What is R? Well, R is the rent cost. And if you go back and read the problem, it says with each $40 increase in rent, 1 unit becomes vacant. Okay? So we're going to use that information in the future to solve this problem. Basically, the rent cost is 1,000 plus 40V, the number of vacant units. So let's think about that for example. For an example, if we have 0 vacant units, the rent cost will be 1,000. All right. If we have 1 vacant unit, R will be equal to 1,000 plus 40 times 1, which is 1,040. If we have 2 vacant units, rent will be 1,000 plus 80, which is 1,080. So in other words, with each increase in rent by 40, you will have 1 more vacant unit. So we're going to use this simple formula to get V by itself. We would subtract 1,000 and divide by 40. That would give us the number of vacant units. So let's just plug in, for example, 1,080 here for R. You would get 1,080 minus 1,000 over 40. 80 over 40 is 2. So that basically tells us that if you increased the rent by 80, that'd be twice 40, so you'd have 2 more vacant units. So, as I said before, this one is definitely a more involved problem, but we have a constraint equation now. We now have the number of occupied units is equal to 30, the total number of units, minus, parentheses, the number of vacant units, which is R minus 1,000 over 40. So you might be thinking, okay, well, why did you narrow it down to R instead of V? Well, that's because we are trying to optimize how much money we're going to make total, and that will involve our rent cost. Okay, so we're trying to optimize money. We need those units in our constraint equation, and you'll see why more further when we go to look at the optimization equation. That's it for step 2 of determining the constraint equation. Again, it's based on what your limited resources. In this case, it's based on your number of units that you have to rent out, which is 30, and more particularly the number of occupied units, because that's ultimately going to determine your total profit for this apartment building. And again, we want to put it in terms of R because you're looking for a rent that maximizes monthly profit, and part of what you're going to do with the constraint equation is you're going to ensure that the optimization equation is in terms of one variable. That variable needs to be in terms of R, since that will determine what you're maximizing. So next we will look at step 3, which is the optimization equation. However, if you have any other questions about the constraint equation, let me know.